Hello, good morning. My name is Joël Gézégou. I'm the director of the C-160 maintenance unit in AIA, which is an aircraft MRO company located in Clermont-Ferrand in France. I'm very proud to be here today to explain what we have done with critical chain, to present you our result, and also to give you the feedback on the implementation. First of all, I will give you a general overview of the organization. So AIA in Clermont-Ferrand is one of the 4 facilities of the SCIA group. This 4,000 people group reports directly to the French Air Force commander. This is a state-owned group with non-profit rules, in fact, and we work mostly on French weapon systems. And the main activity, in fact, approximately 80% of the workload is dedicated to maintenance on those different products. Let's have a zoom now on the AIA organization in Clermont-Ferrand. The organization is divided into business units for aircraft maintenance, conversion, and also rotables maintenance. For those business units, we have what we call support shops. I'm going to call them back shops during the presentation. Those are shared resources between all the business units, and they're organized by skills, in fact. C-160 is 27% of the global turnover of the company. We have implemented CCPM, critical chain, only in the C-160 unit, only this one. It's a big aircraft, big challenges, complex activity, and also big pressure from the customer and real expectation, internal and external expectation for improvements and results. In fact, AIA is the only C-160 MRO provider for the French Air Force, the only one. As you can see on this slide, C-160 is an old daddy. It's a 40 years old aircraft, meaning that it's an aging aircraft with a lot of issues, corrosion issues, fatigue issues, wear issues, and so on. There are different versions of aircraft with different configuration, meaning a lot of variability between aircraft. And we have a cycle of maintenance that is in fact, we have a visit on each aircraft, a visit every 5 or 6 years, really depending on the version of the aircraft. And we perform what is called the splitted maintenance, meaning, in fact, that the aircraft is virtually splitted into 4 blocks, and for each visit, we perform a major overhaul of one part of the aircraft, 1 block, and a minor overhaul of the 3 other blocks. It means that at the same time in the workshop we can have 2 aircraft, maybe the same version, but with completely different program of maintenance, depending on the block. The organization to support that, the C-160 units, my unit, approximately 100 persons, divided into 2 groups. The production group, very skills organized with 4 main skills, mechanical, hydraulic, electrical, and structural teams with supervisors. And on the other side, the technical group with engineering, logistics, scheduling, and execution. And we also have, of course, the back shops, the shared back shops. It can be up to 60 persons at the same time, with, you can imagine, an heavy synchronization required. So this is a picture of the environment where we have decided to implement critical chain. But what for, in fact? My customer is the French Air Force. French Air Force operates C-160. And it's clear for the Air Force, C-160 is the key weapon system for tactical and logistical transport in France and also all over the world for any reasons. And there is a strategic value for the Air Force, and the Air Force is a very demanding customer, in fact. Is always looking for the best efficiency of all its weapon systems. And for C-160, the efficiency is the high level of the fleet availability. The Air Force is also very demanding for financial budget. under big pressure from the MOD for this budget. And so all the improvements we can gain for WIP or for cycle time will be very useful to avoid any huge additional cost. So that means that it's very important also for AIA, first of all, to remain a reliable MRO operator for the French Air Force. But also, it's very important for the competition. MRO environment is subject to a very high competition. And even if we are a state-owned company, we are not at all protected from any competition. I mean that we have to compete with all the private companies, in fact.
Good morning, everybody. My name is Julien Radkowski. I'm the C-160 Unit Assistant Deputy, and I was in charge during this implementation of the dedicated core team who applied critical chain solution to our units. Before starting talking about implementation, I would like to highlight, difficulties and challenges we had prior to implementation. The first one, and I think it's a kind of characteristic of MRO environment, is about variability. We've got variability in maintenance tasks, and because of that, we have a lot of difficulties to follow schedules. We have variability in maintenance tasks, but also between aircraft conditions. In fact, we have very old aircraft to repair, and some aircraft arrived in the AIA are very old. Consequently, we discover at the end of the inspection a lot of more repair work than scheduled. Consequently, we could have a huge impact on this aircraft. On average, we discover 15% more work. The first thing I would like to point out is competition for resources. We have competition for resources inside our unit between aircraft, but also outside our unit between several units and back shops. Last thing, that's most a feeling. In fact, we suffer before implementing critical chain, we suffer from a lack of visibility. And in fact, we didn't know exactly how to focus. That was a big trouble for us and a bad feeling. Consequently, we choose CCPM, critical chain, to fight against these difficulties and to answer the following question: how can we manage variability? I would like to highlight two key points. I think the success is due to, first, creating a dedicated core team, and after, to have a very rapid implementation. You can see on the slide only 11 weeks of implementation. In fact, that's important to monitor the change and to show your people that a critical change is not another improvement event, but that's a real change, a revolution. Before going live, you have to do one very important thing. It's flushing your WIP, your work in progress. That's the most difficult thing we had to do, in fact. And because we decided to reduce, in fact, our WIP from 5 aircraft in docks to 3 aircraft. It's not something very, natural for people to see aircraft frozen. And we have to change our way of thinking and our habits to do that. It's crazy to tell your guy, okay, we are going to wait for this aircraft, and nevertheless, don't worry because we are going to be on time. That sounds a little bit crazy. Now, on this slide, we are going to see what we changed in our unit. I'm sure that everybody in this room knows about the 3 rules of critical chain. I don't want to recap them. I just want to show how they applied to the C-160 unit. Critical chain buffering. We've decided to set an aggressive goal of 100 days for the template for our project, in fact. That's an achievable 30% reduction for an MRO environment. We decided also to change our network. Before critical chain, we had a very unmanageable, badly to detailed network, about 1,200 tasks, and it was very awful to manage. Consequently, we decided to have a much more simplified network, about 300 tasks. Okay, easier, simplified, better for execution. The last thing I would like to talk about on this slide is at the bottom of the slide, that's the difference between the previous solution, the previous template, and the new one. Of course, you can see there is a cycle time reduction. Before critical chain, we had targets about 150 days, and after, now we have a target of 100 days. We, in fact, removed hidden safeties. We were very aggressive on task duration, and we create a project buffer, a common project buffer for everybody, and a shared common buffer, in fact. The second difference I would like to point out is that on the new template, we don't have multitasking between phases. That's very important because we set, in fact, release control points between phases to be sure that when we start a phase, we are going to realize this phase without being interrupted. That's very important. So better synchronization and less rework. Pipelining. We have two levels of pipelining in our unit. The first one, it's a high-level pipelining. That means how to induct aircraft based on your constraint and while respecting your WIP. The second level of pipelining, it's a lower level. It's about an aircraft and a project, how you are going to control the release of work. We had before critical chain 7 milestones. That's huge in a project, you know, and I'm sure that Mr. Parkinson would have appreciated that, because now we only have 3 milestones and only 2 are used to drive priorities. The first milestone is the most important one because that's part of the success of the 100 targets. If that strip, inspect and order the parts to our backshops, we have to be very attentive to that. We have for each release control point, we have a kind of checklist. We check that it's possible to start a phase and we are not multitasking between phases. That's very important. Buffer management. We cannot talk about buffer management without mentioning Concerto. Concerto is our software. It's a common tool for everybody, for production, logistics, engineering, and technical office. This software, in fact, gives a clear list of priority. And with this list of priority, we can have a very efficient resource allocation. We also have what we call a kind of watchdog, you know. We have written rules for resource allocation, well known by everybody. That's very important. Second thing I would like to highlight is as you increase, in fact, the pace of maintenance, you have to increase your issue resolution process. In fact, you have to control your WIP, and with controlling your WIP and no multitasking, you will increase the speed of issue resolution. So now we have seen very quickly the implementation, the difficulties, the challenges, and the way we wanted to address them. There is a last point I would like to speak about, and this one is another difficulty we had during implementation. That's not something we choose. In fact, that's something that's a kind of external constraint we had during implementation. We had a resource attrition, in fact, at the very beginning of the implementation, and it was about 13% less resources. Nevertheless, we managed to have good results and cycle time reduction in the first phase of the critical chain implementation. But this resource attrition did not stop. In fact, it continues, and it went beyond, you know, the critical size of our organization, and consequently, we had some difficulties to have very good results on this part of the implementation. With 25% less resources, we had poor results. Consequently, now we are back on track. We elevated the level of resource, and we are back. We are at the same level as the first part of critical chain implementation. That means 13% less resources, and we expect dramatic change and dramatic results.
The first point in the middle is concerning parts and all the backshops, in fact, the shared backshops. We have very good improvements in this area, in fact, for on-time delivery, for turnaround time. Good improvements that come from two things, in fact. First one is a very aggressive target for disassembly of the aircraft. It means that all the parts are routed very quickly all over the different workshops for maintenance. And the second point is this very simple process for parts. Very simple but very efficient. In fact, for the backshops, it makes their life easier. It's much more easier to schedule the activity. And also for my supervisors, it's very comfortable because they don't have to chase parts anymore. They have time now to focus on the execution of their task. So it's really a big improvement. For the unchanged high level of quality, it's also a good story because, in fact, at the very beginning of the implementation, I remember all the mechanics, they were saying, oh, my boss wants me to work quicker. I'm sure I'm going to do a bad job with bad quality. This was the first reaction, but in fact, it's not the case. We have explained that we're just trying to accelerate the pace of maintenance. We're trying to reduce interruption. We're trying to reduce we're trying to reduce WIP, in fact, task WIP. So we're trying to improve execution of our task. And in this way, nothing happens on the high level of quality. We remain at the same high level. So very, very interesting. For the second point, so these are the overall results. We have a 15% reduction in cycle time. It's a good result, but it's not enough. The target was 30. I will explain that later. In my mind, it's a good result anyway. It's an average result since the go live. So in fact, it means that in this 15%, we have the bad results of aircraft delivered in spring, meaning that at this time we had this resource constraint that really limited our improvement. Actually, at the very beginning of the implementation, for the first three aircraft, we have hit a 25% reduction in cycle time. That is really a very good improvement. And now, after solving the resources problem, we're expecting the same 25% for the aircraft that are currently in the workshop. Also, a very huge improvement in WIP, because now 2 aircraft are back in line in the Air Force. What does it mean for the Air Force, in fact? If you remember the strategic value for the Air Force, that is a high level of availability. They have 2 aircraft ready every day for any missions. 2 out of 56 aircraft that are in service in the Air Force. It means more flight hours, more payload carrying capacity. It's really of value for the Air Force and for all the customers of the Air Force. You can compare that to the replacement value of those 2 aircraft. That can be up to 300 million euro, something like $450 million. Important. And the third point is also good improvement in throughput, a 15% improvement even with fewer resources. It's very interesting because at the same time we had the WIP reduction. It means that we have freed space in the workshop, and with the increase in throughput we have more capacity in terms of production hours. And it's very useful because at the same time the Air Force was asking us for extra work, for modification, and also for an inspection program. So this throughput, in fact, this increase in throughput is currently used in the unit. just to summarize, in fact, the results, we can say that even with this external challenge of fewer resources, we have achieved more aircraft and even faster. It's very impressive. It's also very interesting to talk about intangible results. I'm not going to go through each bullet. I will just highlight some of them. The first one is management processes. We have, in fact, really re-energized all our organization. Roles and responsibilities are very clear for everybody in the process. It's really it's a big strength, a real strength for the organization, and a lot of discipline behind that. It's very, very powerful. It's a great improvement. The second point is now that everybody that is involved in the production process have the same priorities. Everybody knows where to focus his effort. That is very important. We're not working on managers or technicians' intuition, in fact. We are working all together on the same highest priority task. It's also great improvement. The next point is, we have seen in the beginning of the presentation that one of the challenges before this critical chain was a lack of visibility in execution. And in fact, for that, buffer management is really a revolution for us. It's really helpful because we know exactly what tasks are going wrong, what will be the impact on the critical chain and on other chains, on the next milestones and so on. And we know, in fact, we have all the information to design very efficient buffer recovery plan to go back on track in case of any issues. Metrics. We have now very simple, and we have few metrics to monitor execution. Those metrics are, there are only three. Task completion, WIP, task WIP, and buffer consumption. And that's enough, in fact, to monitor execution. I'd like to share with you some lessons. The first one is leadership and involvement. Critical chain for us was a real deep change in our organization, also in our behaviors. I mean that, in fact, it's a huge challenge for people that are not really ready for that. Implement CCPM is not so easy, even if it's quite simple to understand. So leadership is highly necessary to explain the rules, to pave the way, to explain the reason why we are doing that, and so on. So for me, it was very important to be very involved from the beginning of the implementation to now in my everyday life as a manager. Very important to be involved and to support, to help all my managers in this process. It's also very important nowadays for the weekly buffer recovery design, or even during the daily workarounds on the shop floor. The second point, critical change may be a little bit counterintuitive for some people in the organization, some people that may not be ready for that. So it's very, very, very important that all the people that are involved, all the managers that are involved in critical chain may really understand all the rules and the philosophy of critical chain. Why? Just avoid, in fact, going back into the vicious circle that is going to lead to all the issues we know. Flexibility. We have seen that during spring we have some resources challenge. And in fact, after analyze that, we have seen that we need a lot of resource flexibility. How to address that? The first thing we are implementing right now is to develop cross-training and multiple skills capacity in all the teams in order to have this flexibility. We're going to see later the next step for that. But we really need this capacity flexibility.